Ni hao.
All
right.
And these Chinese
I know,
people.
right? Okay. Anyway, all right. The mean value theorem. Use Rolle's theorem. Work with the mean value theorem. Now, mean value theorem. It is not just the angry math teacher.
Good stuff. Yeah.
See? See? All right. Okay. All right. Let f be a function defined on a closed interval here to here. F is continuous on A to B, then it is differentiable from A to B. Now, what's the difference between the parentheses and the brackets?
We include and we not include.
Yes, included. Okay? And this is what has to happen. The endpoints are equal. That's important. The endpoints are equal. So, if the endpoints are equal, then there's at least one number in the open interval for which that the derivative is equal to 0. Now, if you think about it like this, we'll sketch my graph right here. Look, I'll even change up colors. Face. There we go. So f of A is equal to f of B, right? Say yes.
Yes.
Okay, so those endpoints have the same y value, right?
Yes.
Okay, for this to be true, it's differentiable on this interval and they are equal. Okay? So, my point that I'm trying to make is right here. What's the slope right there? 0. If this is going to be true, that they're endpoints, that somewhere in between there, that there's going to be a place in which the slope is equal to 0.
Why do we need it?
Find the intercepts of this and show that f of c is equal to 0 for some number c belonging in the interval formed by the two x-intercepts. Find c.
We just need to find the derivative and say equals.
Okay, so now, let's see. Find the x-intercepts. Okay, x-intercepts. What does x-intercept mean?
The
Y
roots
is
of
equal
the
When y is equal to 0. Okay, so I'm going to go with 0 equals x squared minus 5x plus 6. So can we factor that? Say yes. Say real easy, right?
Yes.
negative 2 and 3.
X,
Negative 2 and negative
yes. Negative 2, x minus 3. So my x-intercepts is going to be x is positive 2 and positive 3, right? Okay, so there's my x-intercepts. Show that f prime is equal to 0 for some number c belonging in the interval formed by the two x-intercepts. Okay. So I need to find where the derivative, right? Let's find the derivative.
2x minus 5.
2x minus 5. Set that equal to 0. So x is how much?
2.5.
2.5, or as a fraction, because I like fractions.
5 over 2.
5 over 2. Okay. No, it's only on the left side. The left side. Yeah, it has to do with the left side. All right, so random stuff, right?
2.5 is equal to 0.
Okay, so is that 5 over 2, is that inside the interval?
Yeah.
That's 2.5, isn't it?
Yeah.
Is that right in between my interval from here to here?
Yeah.
Yeah, there we go.
So it is.
So
It's the hours.
my value, so the derivative equal to 0 For some number c belonging in the interval formed by the two x-intercept, find c. So my c value is going to be here, right? So here, c is equal to 5/2. Yes?
Yep.
Okay. That's what it means. Those are my two endpoints there. My endpoints here, so these would be closed brackets of 2 to 3 in my interval, and it's going to be there. It's going to be 0 there. Let f be a function defined on a closed interval. If f is continuous on, again, closed interval, f is differentiable on open interval, not taking a derivative at an endpoint, then there's at least one number, c, in the open interval a to b, for which that it is equal to the slope.
Wow. Unbelievable. We knew it, no?
No.
Did we?
So, no, this is...
It's like this was finding derivative.
No, but it's not. This is something different. Okay, what does mean besides math teachers?
Average.
Average. So it's the average value. So it's basically that my secant line,
We're just finding the slopes on the interval.
secant line, the slope of the secant line should be equal to my f prime of c.
We're like just finding the slope on the...
Secant line. The slope of the secant line is always just going to be y2 minus y1 over x2 minus x1.
The slope.
Slope formula. Remember, we keep talking about this over and over again. The big idea about this is we're finding the slope. Finding the slope. Okay, slope formula. That's a lot of what we're doing here. Does that make sense? Okay. All right, let's... Come on. Come on, you can do it. There we go. Did I skip too many? No, there it is. There. Verify that the function blah 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 satisfies the condition of the mean value theorem.
Why are you swearing? You're swearing in Russian. You know?
Blah, blah, blah.
I know blah blah blah. I do not say blah blah blah.
Oh, yeah? It's like...
I know. You know, we talk about this all the time. So f of x is x cubed. F
Like this.
Blah, blah, blah.
x cubed minus what?
You say like, it's not like calling someone. It's just
Hey, donkey shake, please.
like,
Please. I'm trying to like teach here, but you have like this weird conversation going on.
You were swearing. I'm
Okay.
explaining.
All right, minus 3x
Plus 5.
plus 5, right? And interval of where to where?
-1. X.
Okay. So this is another notation of actually having to write this. Since this right here, the -1, this has an equal sign right here. This would be the same as saying bracket -1, comma 1. So x is somewhere in between those two. All right, so secant line. Secant line, slope of the secant line. So that actually goes with my function. So it's going to be f of 1 minus f of -1 over 1 minus -1. That's the slope of the secant line. It's a straight line in between my two endpoints. Make sense or no? Did I lose anyone?
No.
Someone get distracted by someone's weird talk about their Ukrainian cheese?
It's like cheese, it's swearing.
Oh, okay. All right, so let's plug in 1 to the f of x.
It's going to be 3.
So 1 minus 3 is going to be -2 plus 5 minus. So
7.
right here, this is going to give me -1. So it's -1 plus 3, right? Say yes.
Yep.
Okay, plus 5. So together that is all over
2.
1 plus 1. So on top I get over 2, which is -2. So my secant line is -2. So using mean value, that's somewhere in between those endpoints, it has to be that. Okay? So, you'll like this. I don't know if you will. Actually,
But it's fine.
okay, you'll like this.
Why we don't like it? It's easy. Yellow. We didn't see yellow on the white. No. I know. Is it a car? Oh, it's a chicken.
Oh.
Look, it's a chicken. Is it a chicken or is it just a bird?
It's a chicken.
No, it
chicken.
actually looks like a bird. It's not chicken.
Chicken crossing the road.
It's not chicken. It's the.
Okay.
There's some previous chickens that were still left over. Okay, so now, mean value theorem.
Yeah.
Oh my god.
What?
Mean value theorem is the chicken crossing the road.
Wow.
So, I start. My chicken's right here, right?
Yeah.
Okay. Well, yeah, all right, there's chicken there. That's quite interesting. Okay, you know.
It's more.
And so, you come back a little bit later. You come back a little bit later, and guess what?
Wow.
There's that same chicken.
Doesn't look the same.
She's not the same. It's her
'Kay.
kid.
He lost weight.
It's the same chicken.
It's her
He's
kid.
kind of more curvy now.
So this is at 8. And this one's when you come back at
What-
11.
what- It's why you have ads?
3, 4 hours.
What is it the way?
because you had to leave. You had to leave. You're not going to sit there and watch the chicken the whole time, right?
Yeah.
Because that's just weird.
11 a.m.
Wait, writing ads
Huh?
as that sign if you use a mail. You
Now.
can short it like this.
All right, so now for this. If this is the same chicken, and we're talking about the same chicken here, because it had like a neat little bow on it, but you guys can't see it from here. So, there, if you come back and it's over here, what must you assume?
It crossed the road.
It crossed the road.
Wow.
You could have gone around.
How
Or I could have teleported.
straight? Maybe it got
Even
under,
if he did teleport, he crossed the road.
maybe it got under the road. Or fly around.
He still
Okay.
Cross
he
the
crossed
road.
the road.
Now, the whole meaning about mean value theorem is at somewhere, some point, he eventually crossed the road. So my path could be, if I start here, he's like,
That's why it's all 3 hours.
You think the chicken is so stupid? Why-
but we can prove
Milo.
mathematically
Okay,
that he crossed the road.
I know.
At some point here, he crossed the road.
Mm-hmm.
So the slope somewhere in here is somehow going to be, at some place in here, going to be the exact same as him going there to there.
Why?
You said the slope is gonna be the same as that, right?
Somewhere in there.
Okay.
Somewhere in there. We proved somewhere that it is going to happen. Somewhere in there it has to be that. Okay? So, the slope is going to be negative 2. Okay, let's find the derivative. So f prime of x is going to be 3x squared minus 3. Okay? Now from here, somewhere my slope should be equal to negative 2. So I'm going to go negative 2 equals 3x squared minus 3. Add 3. Add 3. So I get 1 is 3x squared divided by 3. X squared is equal to 1/3. And x equals plus or minus this square root of 1/3. So I have proven mathematically inside that interval there's 2 places in which that my slope is equal to the average of the slope.
Is it gonna have to be plus because it's distance in this one?
No, these are x values because it's on like a number line here.
Mm-hmm.
So if I have negative 1 here and I have positive 1 here, right?
Yeah.
So I know that somewhere in between it's going to be equal to, so let me see my graph, what was it, negative 2. So somewhere in between here my slope comes out to be that. And there's 2 places. So that means that from here, this is the graph of the derivative, just so you know. This is the graph of the derivative. So this would be something like this. Like that. That's what it means. So I have a place here where it's equal to negative 2, place here where it's equal to negative 2. So it's not a graph of the function, this is a graph of the derivative. It's not too complicated, it's just the idea is different. Instead of setting it equal to 0, we're setting it equal to the slope of the secant line. That's what mean value theorem is. The average value. Where is the average value? And that's what we're finding. Does that make sense? There's my chicken. Okay, and I will go more into this tomorrow. Don't forget, like, share, and subscribe.